Hello, my fellow YouTubers. This is Roy back again. Let's have a quick discussion. And I really appreciate your comments that you guys leave. And I do put a lot of thought into them. And it does help me think of things that I normally wouldn't have thought of. I like that. And keep leaving them, okay? Let's get into a topic real quick, and this one is going to be involving this little magnet with a wheel on here. This is the mechanism that was in the water pump in the dishwasher. So we're going to do an experiment here, and to show you, these magnets are all north facing out, each one of those. And there's obviously an attracting side to here. So there's your south. And then right now I can push it away. Right, and there's your north. So there's a north and south. There's the south because they're attracting to the north. And if I turn it, so it magnetically, you see me turning? Magnetically, I'm controlling the wheel. Has this nice little housing. We're going to stick it in here, and you get the gist of what's going on. This is just a screw on the bottom, and usually I hang it upside down and have it hanging. So let's go ahead and start up this apparatus. Let me get it away. And that's the RPM gauge. And I'm going to bring it close by. And we'll let it start up. We're going to bring it to about we should be showing, let me slow it down. Let's show the reaction. So with these being north, it goes and snaps its way back. This setup here is for a little tiny Edley Scallon PMH. And this is the setup. This is Edley Scallon's PMH. This is the coil for the water pump. This sits in here, and they put AC in here. And AC causes this to turn. So we're not dealing with AC here. We're dealing with half a sine wave. All the norths are out. Remember that. Half a sine wave. So technically, that should always follow and then snap back. See it turning. Go ahead and get this wheel turning. Now, if I take this magnet and hold it up on the outside, all I get is teetering. Because we're not dealing with AC waves. We're not dealing with a full sine wave. And then you can see the speed pickup. And it starts to flutter But watch what happens when we all of a sudden angle the magnet. When I start angling the magnet, the wheel starts turning. Increase some speed on the wheel. Let's put it for another test run. Moving so fast. The wheel. Got a flat tire, guys. How does this rubber come out? Let me show you where the rubber was. This rubber was along the inside. If you go back in the video, it was along there. Interesting. Interesting. Leave your comments. Rubber. What does that have to do with anything, you're asking? Well, let me tell you what it has to do with it. It is an electrostatic buildup. This is the rubber band that goes in this plastic tube. Like so. And it is like a Van de Graaff. Okay, you see the plastic in there? You see the plastic tube and the rubber band. Now what happens here in this rubber band is that there's a plastic pulley on top and a plastic pulley on the bottom. And the bottom there's a little, looks like my fingers, but real tiny and pointy. And there's a collector. And that's usually the negative collector. And this is the positive collector. What happens is from the movement of the rubber band and the plastic, you'll have charge build up on one side of the rubber band and another charge build up on the other inside of the rubber band. And what you'll have is when it gets down to the bottom, your one charge will be released. And when it gets to the top, the other charge will be released out of the rubber band, between the rubber band and the nylon spinning, causing a friction in between the rubber band and the plastic. So, with knowing that, I'm saying that the rubber band inside here is was building up electrostatic. So leave your comments. In regards to the magnetic test here, you can see a couple things out of here is that you can control the wheel using a magnet. Two is you can turn like this was meant to turn in a sinusoidal by adding a twist, because what you're doing is you're taking the field now and you're twisting the see the poles are on the outside, one side here and one side here. The poles are not at top and bottom. So what you're doing is you're taking, if your poles are here, that means your point lines, your axial is out that way, and then no, it's out that way, and then your two sides. So that means you're taking your strength of your magnetic field here and you're turning it. Once you start turning it, you're going to start catching the tail end of this magnet, where this magnet and this magnet and this magnet and the rest of the magnets all are all north facing out. But the positive is facing that way. And also the positive, this is a iron rim, iron spokes. So there's a magnetic field that's in this whole thing, like if it was like a disc. So there's a a lot more to the story here by thinking this through, where your north are out and then your south field is all in here. And what happens here is if I take the compass and let me see if this one actually, we'll check right now. That's a compass ain't working. It's facing the wrong way. That one's facing the wrong way. And we got one that works. So it's got north out, north. So if you get in between these, you'll see there's a north there, there's a north there, and then it switches in the middle. There's a south in the middle. So the south is being picked up. You see that, guys? The south is being picked up in the iron on the backside. So everything in the center here is a south, and everything outside's a north. Sort of like how an atom would be. And you can look at your south as protons, and you can look at your north as we'll call them radical energy electrons, your movable electric wave, or your electric sea, we'll call it. Because out of the two, three, out of the three things in a atom, the proton, the neutron, and the electron, you can look at the electron as the radical one, where it gets to roam anywhere in between any matter at all. And then you have your neutron, which is like a shadow to the proton, which is a positive charge. And this is where you get into with my plasma experiments. And the next plasma experiment you're going to see is going to be pretty damn interesting, because what you're going to see is a more sophisticated vacuum chamber, and you're going to see that I will be using a crystal, and we'll be taking two little 1-inch square mirrors, and we're going to have the light from one side of the electrode have a mirror, and the mirror will be facing the mirror down bottom, and in between will be where my collector filter is. And what we're looking to do here is experiment on seeing if I can have gold show up into the collector, or silver, or bronze, or any. It's almost like this. I'm going to reference this in a strange way to you guys, but in a biological sense, it's like you need a seed. Atomically, you need the seed. It's not like the creation of everything. It's more so you're taking and making matter, and matter appears to be any matter you want it to be, but you need a seed. So what we're going to do is, in our filter, we're going to have a seed of each individual element. We'll do them one at a time, and in these seeds will be a piece of aluminum, or I got gold flakes, I got silver, I got bismuth. So the thing is, it's almost like growing a crystal. How much plasma, or how and what vacuum pressure do I incubate the seed at? This is interesting, very interesting. This is actually growing matter, and as well as expanded matter from a small form of atoms, but getting them to move through the plasma, which would be like the pre-seed, how would I explain this? The pre-seed makeup of all matter itself in its transformed way, without becoming any particular matter, has to have a frequency, and that frequency determines what that matter is to be. So you can look in a way of saying your north and south pole magnetic poles of the planet Earth pull in the energy of sun rays, and which has all the frequencies. Sorry about that. Has all the frequencies, and in sun rays, and it would be sucked in through the poles, and it would be incubated through the center core, and then eventually will be burped out and cooled down, and that's how you get your pockets of uranium, your pockets of gold, your pockets of copper, your pockets of iron, all the ores you see. And all the ores you see also have another attribute attached to the ore, which will be its crystal. And by the process that I'm talking about is kind of how you have to look at. Here goes your oolite, and there's your crystal growing from the oolite, and here is your magnetite. There's a rock, look. There's your magnetite. There's a rock that sticks to magnets. See it pull itself up? So, not to get off topic, but you know I love my buddy Ed Lee Scallon. And I guess if you wanted rocks to be able to be weightless, you would add some iron to them. And then you would want to charge that iron. So that means these rocks are called magnetites. These rocks are obviously have iron in them, and those iron been magnetized, and they become magnetizable rocks. And these are really cool, and these also show you that the process that I'm talking about of the material, on how it's made through the sun rays, through the magnetic poles into the belly, the furnace, as an induction, electromagnetic sea wave. Is in the belly, burping up, pushing out, pockets everywhere. Then you get your crystals. And the crystal, each crystal has a frequency. So I figured, let's go ahead and take the test to a next level. So in the vacuum chamber, there will be, let me just grab one of these, which is not what I'm using, but in a smaller version this would be. But I'm talking bigger, with a flippable lid that locks in. And what we're going to do is we're going to come in, and we're going to have two identical vacuum chambers. And the reason we're going to have two is because one will be the positively charged electrode, and the other one will be the negatively charged electrode. And what I want to do is put different vacuums on each one. and in between them, they would have a certain crystal. So there's actually 3 chambers. There's 3 of those together, different pressures in each one, and the center one is the incubator chamber, and it's the one that'll have the crystal in there along with the mirrors. And we're going to go and start off by using vacuum with light. And what we're going to do is have real atoms, real fusion of light, and that's where everything starts and comes into in the planet. So from the sun. So if we're going to take, I think the best thing where we're going to start off is I'm going to put a nice little sun dome in my ceiling, in my roof, in my shed. And what I'm going to do is have a certain time of the day, the sun will hit that dome and shine straight down. We'll put it to where it lands right on top of a certain area that lights up my center, the center right to one of the mirrors. And that sun ray will reflect through the crystal. The crystal will have to be picked of what crystal it is and what we're looking to incubate. So if we were taking, say, gold flakes, for instance, let's start off with gold. Everybody wants gold. So gold flakes, and we'll find out what frequency gold it would be in. We already know by color what gold is, so we can look on the color spectrum and look and see where gold falls, and then we can go to what materials there are in that color range and frequencies of those materials, and we can process and break it down to be able to take a small flake and grow it into a big bar, let's just say, of some sort, because I'm going to start off with things like, for instance, say if we take a piece of lead, all right? For starters, I bought this a long time ago, and no, actually this ain't lead, this is tin. And I bought this a long time ago, 5-6 years ago. It looks like a bar. So this, they say, is tin, but it feels like lead. It's real heavy. I'll have to put it to a test. But you just need a seed, and then you could bring the other elements into the seed. So you could have other things show up to create sort of alchemy. I want you guys to leave your comments. Hopefully you enjoyed the little quick experiment, but you can see that the electromagnetic field axial, when I turned that, it lined up better to connecting to the back part of the north to south, and then became a sine wave. And then when it became a sine wave matched to the angle that I was holding that apparatus in, this guy right here, it started turning. So that's my explanation on how this started to turn now by using DC pulse and magnets, right? DC pulse north out, and creating a sine wave for this to turn. All right, you guys, leave your comments. Peace out.